We are going to cover the material for lecture 3 in a series of videos. So let's get started with the concept of assignments and variables, which we have seen in the previous lecture as well. Here we have a statement in Python. For every statement of this kind, which is an assignment statement, you have the equal symbol. And there are two parts to this. One is the left-hand side. I will often abbreviate this as LHS. And there is a right-hand side, or RHS. And you can see here that the right-hand side is 3.4, left-hand side is GPA. This is a variable. This is called a variable. It can hold a value at any given point in time, and at different points in time, the value can be different. So I'm saying that GPA should be getting the value 3.4. So whatever is on the right-hand side is evaluated. Of course, here it is very straightforward. This is 3.4, and it gets stored in this variable. Here I have a second assignment. 35,000.0 is stored in this variable income limit. Again, see the assignment operator equals. You can take a variable like counter, use its value, add 1 to that value, and replace the value of counter. So these are all valid assignment statements. You can see that the left-hand side is a variable, the right-hand side produces a value. These are illegal ones, the ones in red. 3.5 equals A. You can't store something into a constant. It always flows from the right to the left. So you're trying to take the value of A and storing it into 3.5. 3.5 is a constant. It cannot change. So you can't store something into that. Again, A plus 1 equals 10. You cannot store something into an arithmetic expression. Here, the left-hand side is quoted. So this is a piece of text that cannot hold a value. In fact, this itself is a value. A in quotes is a piece of text in Python. So this is also illegal. So we have seen the notion of variables. Variables are created or represented by identifiers, so-called IDs. So there are rules for having or naming identifiers. Here are 4 identifiers in green that are all legal. You have to start your identifier with an alphabetic character, A through Z, uppercase or lowercase, or it has to be uppercase or lowercase letter or the underscore character. So here, the first 3 have alphabetic characters starting the identifier. The 4th one has the underscore. After the first letter, you can have alphabetic characters, underscores, or digits. Nothing else is permitted in the identifier. Here is a bunch of bunch of what I would call tokens or whatever that are not valid. This starts with a digit, second smallest. This has ampersand in it. The only special character allowed is underscore. So this is illegal. You can't have question mark. Again, only underscore is allowed as a special character. This is quoted. So you can't have quotes symbols in your identifier. But what is wrong with all these? They seem to follow all the rules. They start with in fact, all of them contain only alphabetic characters. But what is wrong with this? What is wrong is that these are reserved words in Python that have special meanings. There is a bunch of reserved words in Python. You will come across many of them in this course. These are some of those. There are many more. So you cannot use these as identifiers in any Python program. You will see more in the coming classes. As opposed to identifiers, we have literals. Literals are constants. They cannot change. For example, the number 3, it is 3. You can't, 3 is never 4, for example. That is ridiculous, right? 4.5, that is just a number with a fractional part. Winter, in quotes, that is also a literal. It is a constant. It is a piece of text. So if you have a piece of text, you should enclose it in single quotes or double quotes or even triple quotes are fine. 3,4 is not a literal. This is not a literal. This is also not a literal. This is a variable though, winter. Now, let me explain the content of this slide using the whiteboard. All right, let's consider this statement. X equals 10. We know that 10 gets stored into X, but what happens inside? It is very useful to understand this. You will understand the concepts that are coming your way in succeeding classes much better if you understand this idea right now. So try to think about it, okay? Now, when your Python program runs, the memory of the computer is going to contain, so this is your computer memory. From the readings, you know that this contains a number of bytes. Part of it is stored for your program. There are lots of other things also that consume memory, like the operating system, your browser, maybe Word or Excel. So this is part of the memory that is for your program. So this is memory for your program. Now, when you have a statement like this, what does Python do? So to see this, actually it is not important to worry about the rest of the memory other than what is allocated for you. So I'm going to redraw this slightly. So I'm going to ignore the computer memory that is not in your program. So let's not worry about the computer memory in general. Let's simply worry about the memory for your program. So let's say this is the memory for your program. Then when you write something like X equals 10, part of this memory is taken and Python stores 10 into that piece of memory. So I don't know where this will be allotted or allocated or where this 10 will be stored, but part of your computer memory, this is your program memory. So it is going to contain 10 somewhere. And this has an address. Let's say it is at address 17,000. Let's imagine that it can change from execution to execution. And Python keeps track of the fact that this is called X by U. So it stores the address of this location in X. So X is the variable that you used. So Python remembers that X contains 10. So you can, maybe if you want to have an analogy, this would be like your sign that says I-94 or something, right? Or I-35. And this is the actual highway. So this is actually an object that contains the value 10, and X is simply a vehicle for you to refer to that variable. So X at this point contains 10. X, if you land on X, it will tell you where to go to get its value. Now suppose we write Y equals X. So this is the second statement in my program. Then it creates the variable Y in the memory and then says Y and X will contain the same value. So Y also points to the same location. Now suppose I write Y equals 20. Then 20 will be allocated some storage. And let's say this is in 25,000, location is 25,000. Then this link is broken. Y will now be pointing here. So X is pointing to 10, Y is pointing to 20. It is important to understand how Python manages the variables, manages the values, and connects the variables to the values. So these are all objects. This 10 is an object, 20 is an object. X is actually storing the address of 10, Y is storing the address of its value, etc.